Hello, hello. Okay. Test, test, test. Can I hear myself? This is a test. Okay, that's working. Okay. Okay, so today's task is creating an algorithm that creates a path through the world using these stairs. Basically stitching these patches, these elevation patches together. Not sure how many. But if the number is variable, that's fine. And the first problem is getting a list of all of these patches. With their exits and then use some kind of pathing algorithm. The stupidest one would just be follow a random exit. Exit the patch randomly, but of course not in the direction you came from. And don't enter patches here where you've already visited. So this means that the paths could be straight, could be curved, could be folding in on themselves, but I think all of that is fine. Now, what makes this really tricky is the underworld, which is currently always a dead end, meaning there are dungeons, but the pathing should take the dungeons into account and basically be able to route in the overworld, go into the underworld for some time, limited amount of time, I would say, and then appear back on the overworld and continue with the pathing there. Which is actually just another exit. And it's already in pink. So where's a good patch example? This one, maybe. Oh, it's a bit long. Oh, okay, so interiors are of course dead ends and should be. So those are off limits. That's bad. Because there's no way to tell if an exit is into a dungeon level 2 or an interior at level 1. But I could figure that out programmatically. So it would be find all the patches, take a random one, make it the start of the game, randomly follow the graph until you've reached patch number, let's say 100, and that's basically all I need at this time. So the steps are: list all patches with their exits, and that means overground and underground. Then find I think right now I can just pick randomly from the list to choose a start. Pick a random patch as starting point. Then walk the patches in random direction, but not backwards, or in interiors, or into interiors. Okay. Right. And then I'll have to remove all unused exits from the path. Remove unused exits from the path patches. Which brings to mind secondary paths, but there problem for later. Yeah. Okay, so I've removed the unused exits. Hey Andre, how you doing? Remove the unused exits and then I'll have to place some kind of end game on the last patch. But I can do that whenever. It's not something for today. And this list is difficult enough. So I'm not sure I'll finish it today. So let's start with listing all the patches and the exits. I mean, that's actually two things. List all the patches and then list all the exits of those patches. And I did some thinking. The best way, or the simplest way that I could think of, which is usually good enough, is picking tiles in the world in a grid. I'm thinking 3 by 3 and flood filling the elevation patch, saving the I can detect the exits already at this stage. So imagining that this piece of elevation gets flood filled, then I'll walk over this piece, and I'll walk over this piece, I'll walk over this one, I'll walk over this one. So that's pretty easy. I'm not sure how many patches there are for the array size or how many exits, but there are certainly not more than 8, I'd guess. And patches there are maybe 1,000. But I mean, I can just crash and find out if when the number is too low. So now the next question is, where do I put the code? And if I look at the main function, I have here a state machine that controls entering game and these two, initializing the entity map and initializing the light map. I'm not sure why they're only done when coming from the editor into the game, because cold starting the game should also initialize these two, I guess. Yeah, I mean, it's the only place here. So basically, yeah, the entity map and the light map are the game data. And well, that misses the hero. Let's look into the game. I think I call it core now. Hero action, hero turn, initialize hero, okay. And the hero is initialized in the objects, which I imagine is the entity map. Yes, okay. So the whole game is initialized in these two functions, which means I can do an initialize path here. But that will alter the world tiles. And the world tiles are shared with the editor. Okay. I could give the game and the editor two different sets of tiles from the same file on disk. But I'm not sure what the impact would be. I do have a data structure to alter the game world, which is called mod something and tiles, okay. Tile modifications. modifies tile only until game exit. I mean, that's exactly what I need. But I do also need to alter the object. Okay, and it causes retessellation. Remove mods. Okay. So if I modify the world, I'll have to retessellate it. That's fine. But this needs an object. So I can remove the stairs. Let's look how this function is used. Okay, signal. In the bridge. What would I pass here? Alter tiles and retessellate. If the bridge piece is not on, then what's it doing here? Oh, these bridges appear. Okay. So if the bridge is off, then what? This is weird. Oh, if it's off, then make it appear and set it to on. Okay, I get it. But why is there no object? Let's look at how entities are made up. Okay, OI, object index. Anyway, I could just pass the object index here. Or in this case, 0. But would that... It could be misleading, because I don't think these tile modifications will spawn objects, but I mean, I could just comment that. Okay, let's make it. I'll need the mod for the stairs for the path. So I'll just add this. And this here. And this here. And add it in the header file. Oh, this is pretty... Scrolling's pretty slow. Okay, there should be a bridge somewhere. But I don't remember adding one here. It's weird. Nope. I mean, we'll see in a minute if this works. Yeah, that's right, Andre. The map is made by hand, but I'm implementing a procedural path through the map right now that changes every time you play. Okay, I can now modify tiles and patches to remove all the exits. So I can start implementing the algorithm. And it's here, I guess. Okay, here I jump into the game at the editor cursor. Which means... Ooh. Which means I'll have to generate the path from the locations that I pass in, which can be randomized. But at first, they'll come from the editor. And the layer. So, but where should I put this function? It's basically a function of the game, but I think this is all we need. All the parameters we need. And for NVI, did you install it from the AUR? Yeah, I did. It's not in the normal repositories, but only in the AUR. So let's go into tile. Check if it fits somewhere in here. Tessellation. Path. Okay, this is testing. Pathfinding stuff. So I think it would fit in here. Yeah. Okay, editor functions, all kind of stuff in here. All pertaining to tiles, and this is... we're writing a function that is considered with tiles. So... I'll put it somewhere here. This is good. Okay. So I'll need to locate all patches and their exits. Pick a random patch as a starting point. I mean, this is P. And log the patches in random direction, but not backwards or into interiors. And then I have remove unused exits from the patches. Okay, so I'll need some data structures here. But what I'd like to go with the simplest possible ones. And an exit has an X and a Y and a layer, which is basically a vector and not much else. Well, maybe it should denote if it's yeah, it has to. It has to have a is I have to differentiate between exits that are ladders jumping over elevation, or they are holes in the ground going to another layer. And that is, what should I call it? This tunnel, maybe. Yeah. V2 IP and L. Okay, position layer. tunnels. So I have to differentiate between them, because in the overworld there are 2 stairs for each elevation change, and I'll have to remove both of them. So if I know that it's a staircase, I can just jump across the gap procedurally and delete the other. But I have to know. Well, I could actually just check if there's a gap near the stair, and then I'll really just have to save the position, because I'll have to check where the gap is anyway to find the other one. Yeah, let's do that. Okay, this is not needed. Position, layer, and then struct patch, slam path, exit, path, patch, and then I'll have the exits. And let's make it 16. Well, that's too many. 8 is enough. And a patch has only the exits. There's nothing more I'm interested in. Is that okay? Is that right? Pick a random patch as a starting point. Okay, I do need the position. Oh wow, that means I'll have to find a good position. I'll have to find good positions, and good positions in patches, and good patches in the world to start the player from. And that's a whole lot more difficult than just placing 12 predefined starting points in the world. So I'm thinking that may be better. But also well, yeah, I mean, they do have to look pretty good. They'll have to be cul-de-sacs going just one way. So that's a tough one. If I had a list of fixed starting points, and could be 10, could be 50, then I could just find them by a special entity that I place in the world, and then start this algorithm from those points. So I don't have to save the positions of the patches themselves. Is that right? Walk the patches. Pick a random patch as a starting point. Okay, walk the patches in random direction, but not backwards. Not backwards. That's fine. I have all the exits. Okay, I think I'll have to have... What about putting the... Let's just call it patch. And this just path. So path is connecting two patches. I'll have them here somehow. That doesn't make sense. Or does it? Actually, it would be better if I have all its neighbors here. Neighbor 1, neighbor 2. Or even better, neighbors. And then I can... Okay, so it has its exits. If I have the exits which have position and a layer, then I can delete all the unused ones. But those two have to go together too. Okay, so it is this way. One exit, one neighboring patch. So I can't oh, no, but I need all the exits. Yes, these are all the exits. I go through this array, pick one of them randomly, and all the other ones I remove the object at this position, and I make this patch the next patch that gets worked. That looks good. But how do I generate this data? Yeah, let's just name it path. So if I make a copy of the world walk through it, flood fill everything, mark down the patch index, then this is pretty easy. But what about layer transitions? Paths that go into a cave or into a house. Okay, locate all the patches and the exits. Flood fill points along a grid in the world and mark patch index in separate map. When flood filling, remember the exits and porches. What are they called? Stairs, porches. Assign the stairs and porches to the patch number. While flood filling. Okay, this means I hit an unknown walkable tile. I say, okay, this is the next patch. This is patch 27. I flood fill it, and every time I find a stair or a porch, I assign it to patch number 27. This gives me an array of patches and the number of patches in the world, which I can then use to randomly pick one of them, which I won't do because starting points are really hard and they should be perfect. So I think I'll make them from hand. Make them by hand. Okay, so then I have the data. Collect pre-made starting points from world map, or pick a random starting point. Alternatively, if that doesn't work out, walk the patches in a random direction. Okay, so that there's a mismatch here. Walk the patches from the starting point, but I have no way to find the patch of the starting point. Oh yes, I have. I have this marked map for the patch flood filling. Assign the find the patch of the starting point by looking at the flood-filled map. Easy. Walk the patches in a random direction, but not backwards. Okay, this means as I explained earlier, I just randomly pick one of these, one of the paths, and I am not allowed to go backwards, so that's a problem. First of all, there's two backwards. There's a backwards in the overworld and a backwards between the overworld and underworld, which is kind of hairy. I'll do that later. That's too much to think about right now. So how do I not go backwards on the overworld? I have this from the get-go and all the paths. Oh, I don't have not yet figured out how to make this connection. While flooding, assign the stairs and porches to the patch number. Yes, but that's not all I need. I also need connect the patches, the neighboring patch to the exit, and that's a problem because we're walking the map and east and south neighbors don't exist yet, so this has to be a second pass. Okay, first pass. This yields all paths, all patches, and their position of the paths. And in the second pass, I can look at each path. Oh yeah, I have the marked map, so I can look at each path, see where it's leading to, which tile is opposite, look it up in the map, and find out the patch from there. Okay, look at each patch path and assign neighbor by looking at the opposite tile marking in the flood fill map. Look at each path, at each patch path, and assign the neighbor by looking at the opposite tiles marking in the flood fill map. Jesus, okay. That's a mouthful, but it's actually not that bad. Okay, so I have both data structures now completely filled. So I can walk them in random directions, but not backwards. Okay, we're back here. So if I follow this path, I can either try to set the patch to null, or well, so imagine we've stepped into the next patch. We have 8 exits. One of them leads back to where we came from. That's not where we want to go. So we have to set the patch to 0 to mark it. Or we could remember the last patch as a state variable. Check this pointer. If it's the same, we don't go there. That's much easier. That's much easier. Remember the last patch pointer and don't walk path with matching it. The last visited patches pointer. Store the last visited patch pointer and don't walk a patch. Walk a path that leads to it. Okay, so we have don't walk backwards. Now interiors, I guess I should solve this problem, the overworld underworld problem, just to see if this whole thing blows up as soon as we add the underground. Okay, remove unused exits from the patches is then pretty easy, I guess. Unused exits. Okay, you could just set all paths not taken to null when exiting a patch. Then in a third pass, visit all paths of all patches that are null and remove the stairs. remove the exits. But this means if the algorithm does a 180 and walks into a path again, walks into a patch again that was visited some time ago, it's hard stuck. Well, it could also exit. It's not hard stuck, but there's only one path forward, and that's the one it already took, so it's looping. So it has to, of course, now that I think about it, this algorithm must never cross its own path. Walk the patches, but not backwards or into interiors or twice. Store last visited pointer and don't walk a path that leads to it. So how do I prevent it from walking in on itself? Walking into itself? I mean, I could give each patch a flag with visited. Which is probably the easiest solution. Set the visited flag on set the visited flag on visited patches. Great. Don't enter. Okay. Don't walk a path that leads to it. Don't walk past two patches with a visited flag and set the visited flag on visited when exiting. Okay. Set all paths not taken to null. No, that's not the right line. Don't walk past to patches with the visited flag. With the visited flag set. But set the flag when exiting patches. Okay. I mean, there might be edge cases that we should catch if no exits are available. Drop all data and start anew. Or, well, yes. Remove unused exits from patches. Set all paths not taken to null. Okay. So how about, not how about, but what about the underworld? Because this could be very easy, Or it could be crazy hard. Okay, so first, one huge problem is that the underworld is pretty much all just dead ends. There's an entrance, but that entrance is also the exit, which is pretty bad. But it would be pretty easy to connect two dungeons but it would be amazing if your path suddenly drops underground and goes through a dungeon or a cave or the like, and then goes up again. So this is a big problem, and the problem is that dungeons need more than one exit. And if I look at this exit, so this dungeon could reappear somewhere here, for example, but that's also I mean, there's all this space here. Okay, so let's imagine I come this way, and this is not here, and I'll have to go underground. I walk this dungeon somewhere to here, maybe, and I appear back here. Then that actually works. I was searching for NVI. Did you install it from the AUR? Oh, that's an old message. Just got bamboozled. Did you manage to install it, Andre? So under which circumstances does this not work? Let's find another one. This one. It's a small one. This one wouldn't make that much sense. So what if the underground is made up in the same way as the overworld, and then I can just reapply the algorithm until it goes back up again. Or is that lame? I think that might actually work. What if the underworld is made up of the same kind of patches as the overworld? I mean, okay, this brings up a good point. So the stairs, making these stairs the point connecting these patches is pretty arbitrary. It just happens to be the elevation. But I have written down other kinds of funnels that can block or not block a path. Like just trees or stones. So just using these stairs by themselves is pretty boring. But I need to take some time to think about this, because it may be bad to just use these stairs. Because you could just block this whole area with wood, with trees. Instead, and you've altered the path. So is this another exit? That's too much for my brain. Can I change these stairs into something else? No. Because they're all at elevation changes. Okay, so putting forest here does not make it an exit, because it doesn't change the unit of position, which is a patch. We're still on the same patch, so it's not an exit. But is this the best currency to use? These stairs? Or should I leave the stairs alone and place woods instead? I mean, if this is the exit, I can't possibly place a random patch of trees here, because then you're soft locked. So these trees can at most be decorative. Yeah, so I mean, these stairs are the most important part. I'll just run with them and maybe add random terrain placement afterwards. I mean, it is pretty lame that it's just the stairs. So I'll need to add some other hand-placed obstacles that will alter the flow of your game. But okay, back to the underworld. What if the other underworld looks like the overworld? And the main difference right now is that the underworld does not have gaps in the terrain. And the equivalent of the stairs in the overworld would be maybe gaps to jump across. Little bridges that can be there or not. And how fast can I update the underworld to fit in with the algorithm? And also, I mean, the algorithm would work, I guess, flood filling this whole thing. Like this, for example. And it would find the exits. Actually, that's pretty easy. I know where I land. I land here on this porch. I flood fill it. Check for exits. Oh, but with this algorithm, I'd also get the ceiling as a different kind of patch, which is not what I want. Because the algorithm requires me to flood fill the world beforehand. So I know nothing about this porch right here. So I'll have to mark the ceiling, the special kind of tile, so it's ignored. And yeah, what happens if the algorithm is underground, finds an only exit to the overworld, but the overworld at this place is a patch that it already had visited, so then it falls. This is kind of hurting my brain. Let me make some coffee real quick. Well, thank God I didn't go overboard in the underground with detail. Now that it looks like I have to redo it. But maybe I can just stitch it together. And then the exits could be just some stones, and maybe there's a way down, or maybe not. And the underground stays this way. Which makes it more interesting, because it's a contrast to the overworld. So what's missing is actually just connections between the dungeons and more ways to the overworld. Which would truly make the underground just like the overworld in terms of patches. Maybe if I flood this, I have this all as one patch, which is fine, but it loops in on itself. But I can cut it up just by placing jumps here that may or may not be there, which is an exit. And stairs to the overworld, which are also an exit. So the algorithm says collect all the exits, follow one, and remove the others, which requires a network, which I don't have. I have paths. But if I connect this dungeon to this dungeon with an exit, then it can... Well, I'll have to cut these up into pretty small pieces compared to what they are now. So they're all loops. Which means I can cut the loop, which orphans one side. Well, not necessarily. Well, yes it does, because there's just one exit in each dungeon right now. This is not easy to find out what the best solution would be. So here we have overlapping pieces of closed off terrain. Here we have continuous pieces of inset terrain. So if I flood fill this, bearing that I have marked all the ceilings, this is hard to visualize. Okay, so I get this. Okay, so sometimes they just lead nowhere. So if I flood fill this, I get one giant winding path with exits on it. So I cannot send a player down this path only to find out. I mean, imagine this door is not here, but the player walks this way. No, the other way around. Imagine this door is here, but he walks this way, all the way down here, and there's nothing up here. So this long linear path, if there's an exit in the middle, I'll have to cut it off at that point. Basically segmenting this linear stretch. How do I make this easier? I mean, I have the same problem up here. This might be the exit. There's this whole chunk over here. This giant chunk. That's empty. Which I would solve by dividing it. Which I can do here pretty easily. Basically, by subdividing each dungeon and connecting each subdivision with the others using exits. It would maybe look something like this. Water. So then this would be an exit. This would be an exit. Okay, that's just turning it into patches. But what I'm looking for is something easier. Maybe the dungeons really are just linear, but that means... Oh, okay. Okay. The problem is when they're linear, they have to form a circle of some kind, which means the exit is right near the beginning, which is bad if you're searching, if you're looking for a linear path. But well, not that. That's just what I was thinking about. Is you could fake it and take the overworld entrance, match it to any dungeon in the underworld, or rather the other way around, match the exit to any location on the overworld. But if you play this, you know that you just made a circle. So if you appear somewhere completely different, that's weird. So the dungeons must not be circular. There'll have to be an entrance on one side and an exit on the other side, like here. But all these dungeons are circular. I mean, it's definitely less work making them more linear than doing them all from scratch. Okay, this walks over here, over here, over here, over here, over here, over here, up there, down here, over there, and then back to the start. But I mean, it's not cheating if the new exit is here, which would put it right over there. So maybe the teleporting exit is not a bad idea. Which brings up another point. Can the player go back? Can the player go back? I mean, it's irrelevant here because it's trivial to make this work with teleports, but is it a good idea? I mean, I'll just suppose they can from now on. So the player walks along. This is the only exit. They enter. They're in a labyrinth. They find their way to here, maybe, where there's another exit. But they continue on and get completely lost somewhere down here. So maybe a third exit here. let's try it with this one. 1, 2, 3. So placing additional exits will take me maybe a few hours. Reworking the makeup of these dungeons will take me probably a week at least. So with the exits being teleports that the player knows nothing about, it's going on in the background, then still, why would I walk all this way, find an exit here, keep walking, come to here and find nothing? Then I'll have to go back all the way and take this one. Or the alternative, even worse situation of player appearing here, walking all this way up here, and there's nothing. And then they'll have to backtrack this giant path back to here. Okay, this would be easier if the dungeon was circular. If it's circular, if the dungeon is circular, it actually doesn't matter. So where to do I teleport? Or do I even have to? Okay, I'm here. And then I'm here. Which is like this distance. Which I could chop this off here. And it would make sense from perspective of a path. But what if I want this path underground to be longer? Do I make it just one giant path? That's not good either. But this could... I could also randomize the entrance. So you step into a dungeon and you're not exactly at this one, but anyone in the world where you then have a linear path and a bit extra in a loop, and you appear somewhere in the vicinity. Actually, this sounds pretty nice. This sounds pretty nice. And saves me a whole lot of work. So with that in mind, I flood fill the underground. I think I don't even have to. I don't even have to, because I can just say the player cannot go back into dungeons once they've exited. And then when they enter a dungeon, they can choose which exit they want to take. And these exits take them to specific spots on the overworld. No, that's stupid. That's just one exit. There's just one exit. For now, at least. So, for the algorithm, I collect all the exits from all the dungeons and make the hero appear randomly in one of them. Okay, but the dungeons have to meet the theme of the overworld. I think so. So I could hash map the entrances and choose a dungeon that's nearby. Or I could mark the exits with what kind of dungeon it is. Or I could just noting that dungeons must be circular. Okay, how do I could reskin the dungeon. Which is not, I mean, it's not that hard, but handmade dungeons are better. And yeah, so how would that work for the algorithm? The algorithm now has a path on the overworld. It chooses a staircase in the underground as the next exit, it follows that staircase, and it needs to know where the path will continue on the overworld. Each patch and assign the neighbor by looking at the opposite tiles, marking if collect pre-made starting points from the world. Find the patch of the starting point by looking at the flood-filled map. Walk the patches in a random direction. Store the last visited patch pointer and don't walk a patch that leads to it. That's actually idiotic. I'll have to store all the visited pointers. Oh no, that's just another thing here. Okay. That's the don't walk backwards. It's not the don't cross over yourself. Okay. Don't walk past patches. Visited flag set. Okay, if no exits are available, drop all data. Remove unused exits. Okay. There's more to this. When encountering porch leading underground, follow it and flood fill the dungeon to find Okay, I think the underground paths have to be found first. So first pass flood-filled points along a grid, the world, and mark patch index and separate map. Okay, while flood filling, assign the stairs and porches to the patch number. Okay, makes sense. Second pass, look at each patch path and assign the neighbor by looking at the opposite tiles marking in the flood fill map. Okay. But I still need the underground patch and paths. So well, I can actually make this without pre-calculating them. When encountering a porch encountering a dungeon, flood fill it and mark its path. Encountering a dungeon. Okay. Third pass. Flood fill the underground and mark all exits. Why would I do that? Encountering a dungeon, flood fill it. Why would I need to flood fill it? When there's just an entrance and an exit, always. And encountering a dungeon. Okay, let's step back a bit. I'm creating this path so that it's to make the world linear. The overworld is non-linear, but the underworld is linear. So this algorithm really shouldn't have to do anything underground other than returning back to the surface. Is that right? So when the algorithm goes into a dungeon, it just picks a random patch nearby to re-emerge. And continues its path there. That's actually stupid. Why not leave dungeons as they are and just pick sensible exits that are on another patch. So then the algorithm goes down, flood fills it, finds the exit, and follows it. But this brings with it the constraint that dungeons cannot start and end on the same patch, which is a bad constraint. So without this limitation, the algorithm goes down here. It knows that you have to come up somewhere, so it can just pick one. Oh wow. Maybe it pops you up where you were. And dungeons are optional. It reminds me of Dungeon Siege. Sorry. Reminds me of Dungeon Siege. A world where you would go up and down, over and under. Through mines and dungeons and forests. All in one go. Is this what I want? It sounds pretty amazing, actually. But randomizing the dungeons is also pretty awesome. So one problem is solved, or basically solved. The appearing back out of the entrance. But yeah. Okay, so if I want to randomize it, hard part is figuring out where to put the player when they go upstairs. Okay, so this is actually a stairwell inside a building. So let's imagine I go down there, I come back up here, then so maybe I just place a whole bunch of stairs down. In the overworld that might be picked up by the path algorithm. Which would then remove all the unused ones. Or you really just go down there and you go back up. That would enable the player to skip it. And it would be super easy to implement. Super easy to implement. Thanks, YouTube. So maybe I'll do that. I flood fill the underground. I take all the entrances. If a player goes into a stairwell in the overworld, they get put in a random entrance, in a random dungeon. In all the other entrances in the dungeon, bring them back to where they came from in the overworld. I mean, that sounds kind of fun. So third pass, flood fill the underground, mark and collect all entrances, exits. When encountering a dungeon, do nothing. No, this is layer 0. When encountering a dungeon, flood fill it. Encountering a dungeon. Staircase down. Check if leading to layer 0. If it is, choose a random exit entrance from the dungeon. Choose at random from the dungeon exit list collected in path 3. Pass 3. If not leading to layer, if leading to layer 1, do nothing. Do the usual. Okay. This has dungeons pretty much solved. But this kind of feels like cheating. Yeah, I don't really feel good about this. I feel the path should continue underground for some time and lead to somewhere else. Problem is finding where to reappear the player in the overworld. I mean, the correct solution would be just to make new dungeons. Dungeons that lead from one point to the other. And if you think about you think about storytelling, that is actually the way to go. Because it's a forward momentum. I mean, making them linear is not that hard. Just have to split them and combine them with their neighbor. Or I mean, if I come in here, then I'll go out here. That's still quite some distance. Of course, I'll have to sacrifice this part. Place the entrance here, exit here. And then I would appear here, which is not ideal. But what if entrance is here? And okay, this looks nice. Could place it here and bring it around here. That's huge distance. That's actually fine. So maybe I'll just have to split them up into patch size. Well, it's really hard to see. Okay. That's better. So I can add one. Okay, here's one. Can add one here. And bring it back up here. That works. Okay, so I'll have to go over the underworld and split it into sensible chunks. Which will take a while. But it's actually not that bad, I guess. Yeah. And okay, with this solution, check if leading to layer 0. Okay, with this solution, the algorithm has to detect. Okay, it makes that on the fly, maybe. Or that's a bad idea, maybe. You step on the algorithm chooses a staircase down as an exit, goes down there, flood fills the dungeon, finds the exit, well, no, that's what I was talking about earlier, I guess. The algorithm, the underground is linear. The algorithm doesn't have to do anything with it, but needs to know where it reappears in the overworld. So yeah, it flood fills, finds the exit, follows it one layer up or two, and how does it find the patch? overworld. Collect pre-made starting points. Find the patch. Walk the patches. Store the last visited pointer. Don't walk paths to patches. Okay. There's no neighbors. There's no connection between the underground and the patch above. Well, I do have... How's this filled? Look at each patch path and assign the neighbor. Looking at the opposite tiles marking the flood fill map. Okay, yeah, so I can find the patch by looking in the flood fill map and continue from there. Okay, so walk the patches. If encountering, if choosing a staircase down, flood fill the that leads to layer 0, flood fill the dungeon to find the exit, and find the world patch by looking at the flood fill map. Store the last visited patches pointer. That is a good question. What about pointers to the underground? Look at each patch path. Assign the neighbor by looking at the opposite sides. Leave underground exits null. Set all paths not taken to null when exiting a patch. Then the third pass, visit all paths of all patches that are not null and remove the exits. Okay, so basically staircase down won't get removed. Okay. be right back. Okay. I was thinking maybe I should move this code to an extra file. And name it playthrough or something like that. Or session. Or run, but run is ambiguous. Maybe prepare. Because it's not just the algorithm. There are a whole lot of things that need to be set up each run. So maybe I'll call it run. Yeah, there's no run time or anything like that, so. Great. Playthrough operation. Playthrough preparation functions. Okay, and I'll need the tiles. And I need to include it. Plus decoration. It makes sense. Stairs. These comments still around. Yep. Comment in comment. Yeah. All right. Initialize path. So I'll need a flood map. That is world width times world height. And flood fill points along a grid and world and mark each patch. Patch and separate map. Then I have the patches. I'm guessing 1,000 are enough. And then I was thinking about visualization, which is not that easy. But actually would be pretty good to have. And also I need a way to look ahead. Which was actually always the debug mode. Wow, okay. What happened there? Oh, escape is debug mode, okay. So when I go here and go into debug mode, then I'm limited by the vignette. So that's not all that helpful. Could just run the code on the main tiles just to get started, because that will show up in the editor. Maybe I'll do that. Okay. Locate all patches and their exits. Let's just work like this. Flood fill points along a grid in the world and mark patch index. Separate map. Okay, I have the map. So I need the number of patches. I need a counter. Actually, I need X and Y. Y is less than world height. Y plus equals 3 to make it a grid. X, X, world width, X. Okay. Flood fill points along a grid. So we'll need a flood fill function, which I already have in the editor. Actually, it's in the tiles. Flood clear tile themes in area of same height. Okay, I know this is a two-step algorithm because there was some kind of problem. Clear and insert. Okay. Flood patch. This is X, Y, layer. Usually struggle while working long hours. If you take breaks regularly, short breaks, that may help. But yes, I feel it too. After 8 or 10 hours straight programming, I just become unproductive with muddy thoughts, and at that point it's better to stop and come back at a problem with a clear head. At least that's how it works with me. So this is the replacement and initial. Okay. The I and there's no old I. Okay. Insert. This is void. Then I need a clear function. Do I really need it? Well, anyways, I get tile. If tile is height and tile is height and tile is tile index. I don't think I need it. Because there's only ever one flooding going on. So I need the tile. And if it's 0, return. If what times what height plus width. If it's not, if the flood map is not 0, turn. To put and then we set the flood map to I and do the same with all the adjacent fields. And that should be all. Now, it is pretty bad that I don't have a way to visualize this. Could I come up with something? Yes. I could just make a new editor mode. But then I'd have to run this function on something. Actually, I don't really have to. It just has to run once, and the editor can color the tiles depending on the flood map. Okay, that was too early. Okay. Where am I? Okay, so every 3 tiles or so will flood the map, and if there's a tile there and it's not been assigned a patch number yet, then we'll flood it. We'll flood it with the number. Why did you decide to start streaming? I just wanted to show more of the game. That's about it. And maybe build a small community, but that's pretty hard. But we'll see. L, is this correct? Yes, I think so. X, Y, flooding is in, I think it's 0. No, it's 2. And the number is, and patches. Turn 1, turn 0, 0, and if equals 1, patches plus. Patches is defined but not used. Makes sense. A previous prototype. That makes sense too. Okay. Let's see if we can add a mode in the editor. Or maybe it's better to do this in the debug mode. Yeah. So let's remove the vignette. And that's fun. And I don't have core dumps enabled. That's great. Enable debugging for this session. Yes, I'm in GDB, why wouldn't I enable debugging? What? Debug info D. Okay, that's something different. Thought it asked me if I want to enable debugging. Okay, that works. Why are there so many frames? Okay, that makes sense. Recursive. So it's frame 0. Cannot. Okay. It looks like the function just crashed the stack. Could you tell me the message? Seems like the function didn't exit the recursive flooding. Turn 1. Patch 0, return 0. X, Y, 2, number of patches. Where did I go wrong? What width, what height? X, Y, 2. That's initialized. Quite sure why this isn't working. I'm stumped. Great, thank you. Just had to recompile. That's a classic. Then let's see. MMP. Oh yes, yeah, I said it's better to do this in the debugger. So if I crash the game, then I have to run it in the debugger. Oh, so it's not solved. Tile at XYL2. Why is the Y value, or the Y value not increasing? That's super weird. Y +1, y -1. Plus equals 3. Well, I'm stuck at the easiest part. That's classic. Doesn't make any sense. So it comes in at some tile. If there's not if it's empty at this spot in the world, it just skips, goes to the next tile. If it's already set to a patch index, it leaves and goes to the next tile. If those two things are not true, then it sets the patch index okay. I think I see the problem. What? No, I don't see it. It sets the flood map patch index. It calls itself with 1 to the east, then again to the south, then again to the west and north. Each time it checks the surrounding tiles for if a tile exists, if a patch is set there, and if not, it sets the same patch index. And then it returns. feeling pretty stupid already. Okay, plus equals 3. Let's just try 4. Yep, crashes. And crashes. If only GDB would tell me what's going on. $140x 7y. Oh, okay. This is totally out of bounds. I mean, not out of bounds, but it's not in the world map. Because that is... Please tell me I have it somewhere here. There it is. Yeah, the song is pretty nice. It's I can show you. It's on YouTube. It's an 8-hour long 8-hour long song. Athena 4, I think. And it still crashes. Same error. Cannot access memory. What is going on? Detaching new thread. Segmentation fault. Tile 91. Yeah, thanks. That doesn't really help. Is it the layer? Am I out of it? Hero. Node layer. Layer 2. Oh, it is correct. Why, oh why? Run. Does it flood something so gigantic that it overflows the stack and crashes? That is a possibility. But why would it do that? There's nothing that giant, and the patches are pretty small. And it wouldn't just flood this here. I can flood these patches, and these are pretty large with no problem at all. Don't get it. If tile is 0, quit. If it's occupied, quit. Do I have to check? Let's just try it. Nope. I wonder what the number of patches is. But it looks like it just descends down and dies. Okay, if it's this hard to find a problem, then normally there's a huge failure of understanding what's going on. This is basically the same function, except I skipped this part. But I don't need to clear anything because my flood map is 0. Initialized to 0. Maybe the I is the problem. No, because let's do it exactly the same. Put the thing to all directions, and that's it. Oh, okay. It may never. I see the error. I see it. It's because this is always 0, so the flooding sets it to 0, which is the test to check if it should actually do it. So I have to set this to 1 or initialize the map. Rather set this to 1. And then subtract 1 later. I guess, at least I think that's what it is. And it works. Okay. Good. So, flood fill, mark patch index. While flood filling, assign the stairs and porches to the patch number. Okay, that's a bit more involved. If tile object okay. Assign the stairs and porches to the patch number. So that's a path. Stairs. So that's 53, 54. Plug stairs. Okay. I guess 140. Teleport is also 132. Obstacle stairs. Okay. 145. And stairs and porches. 214. 215. One, two, three, four, five, six, 7. 53. Okay, and that's T I 53, 54, 40, 32, 145, 214, 215. Then I take the patches. I paths. Okay, I think int and path. P to XY L equals L. We're flooding assign stairs and porches to the patch. Second pass, look at each patch path and assign the neighbor. Okay. And we're crashing again. Okay, T is not null. Patches I, okay, that might be a problem. Depending on how many patches there are. Yes. 1200. That's more than I thought. So let's make it 248. And it works. Okay, we have the patches now for a second pass. Assign the neighbor. For I equals patches, no, 0. So we go through all patches and look at each patch path and assign the neighbor by looking at the opposite tiles marking in the flood fill path. Okay, that's a bit more involved. So we'll make a placeholder or a stand-in for the path. Just to not go insane. Wrong. Patches. Did I call it? Patches. Without a T. Paths. O need to go through all of them. Okay, so we need a... Why is there no eye here? Because I didn't make one. Okay. Okay. Number of paths. So for each patch, each terrain patch, we go through all the paths that were found. And we can do that here actually. No, we can't. Okay, we get the path. Set but not used. Okay. At each path, patch path, and assign the neighbor. Fill a separate special map with patch disease. Assign patch neighbors using patch. Looking at the opposite tiles marking in the flood fill map. Leave underground exits null. Should I have marked them then? I guess so. Look at each patch path. Okay, that basically means actually not sure I'm doing this right, because these things are called ladders. Okay, so they're missing. Ladder 607. That's funny. There's the check. Okay, it's 1, 2, 3, 4, 5, 6, 7, 8. And there are the letters. So let's switch on that. Oh, maybe I should have. Yeah. I should have saved the type. Because it's right there. Okay, switch on the path type. Case ladder. Find direction across. No, not direction. Find tile across gap. and then all the others. Look at each patch path and assign the neighbor by looking at the opposite tiles marking. Leave underground access. Oh, okay, so what else do we have? We have porches and stairs. So these are ladders. Then we have ledges. Don't think I added the ledges here. And ledges can go. Nope, they don't go here. Stairs and then porches. That's 53, 54, 140. 145. Then we have porches. 214. 215. And what that means is stairs. Stairs go directly down one layer, same tile, porches, down and one forward, but I don't have the direction for them. So I'll have to drop one layer down and search around the position. And I can do that for not all of them, but for the stairs too, in case there's an error. And the ladder, which is very badly named, is find gap, find tile across from gap. That should actually be a separate function. And it's a function to search for an exit. Yeah. So that's returning a position. Find exit. I find exit int p, no, int o, y, int p, int l. Returns exit location of, tries to find exit location of y at tries to find. What happens if it doesn't find it? Can't return 0, because that'll screw things up eventually. So I'll have to pass an out pointer here. P, okay. Take P. If it fails, continue. So now this gets more complicated. Find the gap, find tile across the gap. Then I have a isGap function. Vertical gap. This sounds well, two vertical gaps doesn't make much sense, but if tilelet well I need all 4 directions, so that doesn't help. Well, let's just do it. If t equals tile at p dot x p dot y l plus 1 equals null, then we have east. If we have -1, then that's west. +1 is south, and -1 is north. So if we have the gap, we can return, we can set out to p dot x plus 2 p dot y, comma l -2 plus 2 -2. That should work. And just to make this easier to read, set the out to 0, 0, and if the length of out is greater than 0, turn 1, and otherwise we will return 0. PGH is a pointer. That's correct. Whoops. Expected argument. Used. Oh, what? Oh. Too many arguments. Oh, I do have to return the layer. That's bad. We declared. That's true. Compatible. Okay, yeah. Great. Okay, let's grab that. It compiles again, that's good. Okay, so now for stairs and porches. Is this actually correct? Not really. If I put... Well, it kind of is. If I put a staircase right here, the code is incorrect. But I would never do that. So staircase would go there, and then the code is correct. It's correct here, it's correct here. It wouldn't make sense to place a staircase here. Correct here, correct here. Incorrect here, incorrect here, incorrect here, but that's fine. So yes, the code is correct. If the stairs are placed correctly, which they should be. So then I'll need to find the exits for stairs and porches, which is easier. Is it? They can only be cardinal. So, and one layer down. And first one is it at exactly this location? -1. Oh, okay. This function could also be called for stairs underground. So we'll first need to find out if we're searching for... Oh, and they could also go 2 layers down. Okay, yeah, I'll take a short break. Be right back. So I'll have to check all layers, which means a loop probably. And I'm going down or up. Each number is an entity in the switch case? Yes, Yes, correct. And the I is, oh, no, that's not right. If layer equals I, I'm not searching the same layer, searching the others. So I have 3 layers in the game, and I want to find the exit of a stair, so I'll search the other 2 layers. If the yeah, I'm not searching for a gap, I'm searching for if there's no tile, then that's it. If the tile, well, let's make it this way, it's not 0. The tile, well, I better make a shorthand function for this. Is transport a portal? Is portal, yeah. Pretty easy. Is portal. So if the entity we found is a portal, or a portal is on the tile, then we found our candidate. These these pointer arguments, the pointer returns, are pretty ugly. So I have to put it there. Would you care to explain what px and py is? Yeah, sure. Ask any question you like. That's why I'm here. So px and py is, in this case, always a position, and v2i is just a tuple of integers. It's just 2 integers, x and y. L is the layer, basically the z variable. But because this game is mostly 2D, it's split in 2. So if I want to find the exit at position P, then I just pass it in, and it just has x and y, no other members in the struct. And yeah, I'm making you create the types v2i and v3i, or are they from the C language? They are just structs I made. If I look in my structs, it's the first thing here. Type def union. There's nothing. There's no vectors in C, unless you make them yourself. And this is just a struct. These are the x and y, and this is just a handle to access it, like an array, if I need to. But I don't even think I used this much, if at all. And then there's the vector 3 with xyz and aliased to RGB for colors, and the same for v4, and then there's floating point variants for all of them. So it's pretty simple, nothing fancy. Yeah, sure, welcome. So if we found it at that position, that's good, we can return it. And the same thing for all the spaces around, which I actually can make shorter. With a trick. So I'll take the direction, because I'm searching in all directions on each layer. And well, this is actually not good. Call it K. And get a vector D for the direction. And then it's D to I to D. I can't remember my own functions. DI to D. Direction to what? Direction index to direction. Okay. Whatever. It spits out a vector that points in the cardinal directions. So I can plus d point x and plus d point y. I think this explodes in my face. If tile height is 0, continue 34. If is part is 0, continue, else. Okay, that's much more readable. Okay, what I'm doing is search. other layers for exit of portal. Search all directions. Okay, this is the find exit function. I don't have diagonals. These are just cardinal directions, but I think that's okay because unless I made an error in the map, this is correct. Oh, this skips the case where the exit is directly below and not offset by a direction. So make that a special case. Okay. That should do it. So where were we? Look at each patch path and assign the neighbor by looking at the opposite tiles marking in the flood-fill map. Leave underground exits null. Okay, this is of course complicated by the fact that the flood map integers start at 1. Which is pretty stupid. But would be a huge penalty to fill it with -1s. So let's just keep it that way. And well, let's mark it like this. Assign the neighbor. Find the exit. Okay, we have the exit in position exit. So we can look it up in the flood-fill map and assign it path. Dot patch n. Well, n is a bad name. Patch path dot patch. Well, it's also not a good name. Let's name it next. Path.next is equal to flood map position of the exit dot x dot y times what height plus position exit at X. Is that correct? I think so. -1. Okay, this is the index. The patch index. So we have to we fill the patches somewhere. Set some path stuff. Visited a number of paths. Okay, there's not much to set. Paths. Well, this is pretty gnarly, so maybe break it out. To a variable. Well, it's fine. Look at each patch path and assign the neighbor by looking patch neighbors in paths. Leave underground exits null. Not sure if that's still accurate. I think it's not. I'll prove myself wrong later. Look at all patches and the exits. Okay, that's what we're doing. So we have all patches and all their connections to their neighbors. As far as I can see. Collect pre-made starting points from the world map. Okay, I don't have those. We'll use the passed in P here as a starting point. Find the patch of the starting point by looking at the flood-filled map. Okay. We have the starting patch. Let's comment that. This is basically the same as this. And with the normal P, find the patch of the starting point by looking at the flood-filled map. Got that. Collect pre-made starting points. Yes, I have that. Walk the patches in a random direction, but not backwards or into interiors. Oh, that's true. That's a problem again. That was solved. But now with the linear underground, it's a problem again. But I can check the exit, the paths, I could save. I did save the layer of the paths. No. PE. So I can assign path. The position of the exit of the path and the layer of the exit, because I have that. And the exit is p.z. So then I know, because all interiors are on the middle layer, I know when a patch leads into an interior. So I'll not take it. Or I remove it outright. Or I could mark it. I'm sorry. I could mark it as visited. Just ignore it. Or no, it's easier to just check the layer. So walk the patches in a random direction. I'm not sure if I should break this out in another function. But yeah, maybe later. Okay, so this is the whole part of generating the path. And for how many steps? I think 100 is okay for a start. So while n is less than 100 and n is the number of patches we've walked over, store the last visited. Okay, walk the patches in a random direction, but not backwards. Okay, I don't know what direction the exits point. That might be a problem. But actually, maybe. Who knows? Doesn't matter right now. But I can walk them randomly. So I have my starting patch, and I have all its paths. And I can randomly pick one. Does that make sense? And paths, yes. So I have a random path now. I'll need another placeholder. Just call it next. Next path is this one, but it could be visited. Oh, that doesn't work. If an X is visited, then try again. Now this could, of course, hang up if all paths are marked as visited. And I'm sure this will happen right away. But I'm not sure what a solution would be. I mean, we did get to the patch, so there is a way out. And in the worst case, backtracking is totally fine, I guess. So we'll check the tries. Actually, this is better as a do while, I think. So we come to the start patch. Say, okay, we've tried 0 times. We pick one path at random. If it's visited, we do the same thing again. And if the tries are higher than... Well, that doesn't make sense. Higher than the number of paths times 2 or something. Because we could always try to use that single one for thousands of times actually. So let's make it, let's just make it fixed at 100. And in this case, we reset all the paths. But what if the patch doesn't have any paths? That would be possible. But then I would have to change the P parameter. So someone outside of this function has to test this. Or what could be a good fallback? If there are no paths in the starting patch, I mean, we're just done, I guess. And likewise, we could just give up here after 100 tries, but that's pretty bad. Oh, and this is also, this shouldn't be the starting path, should be the current path, current patch. Because it will change. Okay, so the next patch. No, that's the path. Okay, this needs a better name. Next path. Reset all the paths in the patch. And that that should guarantee that we can move on, unless there's an error in the map, in which case this would break. Okay, let's just make it like this. Or return 0 or something. Okay. So this is the path. We've found the path. Find a path to go. And then we go that path. by setting the current patch to the next paths. NX, did I really call it NX? Yeah. Okay. Current patch is the next patch of the path. We set the visited flags failure. How long have you been programming C? I learned C in school. So I've been programming it for a long time. But after school, there was a long stretch, like 5 or 10 years where I hadn't touched it. But now actively for about 10 years. Do I do game dev professionally? No. Maybe someday. Go with that path. Okay, so I have the path. And what I want to do with the path was store the last visited patch pointer and don't walk a path that leads to it. Okay, I have to set the visited flag. So current patch visited is 1. Is that the correct thing? Yes. And I don't, yeah, here's where I rejected, okay. Next path, there's no visibility flag on the path, so this has to be next patch visited. Okay, next path is misleading. I'll just use the path. If that's possible, yeah. Was just lying around. Find the path to go. Okay, that's a stupid comment. While path next patch visited is 1, retry. Then visit it. First I have that's wrong. This is right. Oh, that's also not current patch visited. Yes. Okay. It's getting a bit muddy. Generating the path. Store the last visited patch pointer and don't walk a path that leads to it. I have done that with the visited flag, no? Yes. Don't walk paths to patches with the visited set, but set the flag when exiting patches. Okay, that I don't understand the difference. I don't know what I've written there. Oh, the one is crossing over yourself. No? Yeah, that's this one, visited. But store the last visited patch pointer. Don't walk a path that leads to it. Okay, that's just obsolete. Don't walk onto visited patches. I have that. If choosing a staircase down that leads to layer 0, flood fill the dungeon. Okay, what I have forgotten about is the interiors. So I don't want to go along a path that leads to layer 1. So all path PE LE equals 1. Don't want that. That should take care of that. Okay. Go that path. If choosing a staircase down that leads to layer 0, flood fill the dungeon to find the exit and find the overworld patch by looking at the flood filled map. Jesus. Choosing a staircase down that leads to layer 0. So that's basically a special case. If path LE equals 0 has moved to underground, flood fill the dungeon to find the exit. Great. This will surely crash when I run it the first time. Let's move to underground. What were the flood filling functions? Okay, that's not what I need. I need a whole another flooding array. Is there a better option? So we know we moved down into the underground. But how do we find the overworld patch that we will emerge to? Choosing a staircase down, flood fill the dungeon to find the exit and find the overworld patch by looking at the flood fill map. Yeah, that's... And I can't apply the same logic for the underworld and just straight up flood everything, because it's not neatly divided. Well, we'll go to sleep now. Will you stream tomorrow? Tomorrow is Christmas Eve, so I won't stream tomorrow, but I will probably stream on the 1st. Okay, there's a small off chance that I'll stream tomorrow, but probably not. So I think the day after tomorrow I'll stream again. And have a good night. Thank you for watching. Merry Christmas to you too. Thanks. Yeah, it's been nice. Thanks for hanging on. Appreciate it. I'll be off soon too, so no worries. See you next time. Has moved to underground. No exits are available. Drop the data and start anew. Remove unused exits from the patches. Set all paths not taken to null when exiting a patch. Then in a third pass, visit all paths of all patches that are null and remove the exits. Okay, so that's the thing I'm actually trying to do this whole time. When using a staircase down, check if leading to layer 0. If it is still about a random exit in dungeon list collected past 3. If leading to layer 1, teleport below. If on layer 0 and entering a staircase up, return to the same overworld position. Yeah, well, I just discredited all that. Okay, so what's left is flood filling the dungeon, finding our way back to the surface, and nuking all the unused paths. That's about it. So alright. I don't even have to check if this builds because it won't, but this is, well, it's in the middle of things, but it's quite a good point to stop for today. And yeah, I wish everybody a nice holiday tomorrow, and I'll be back on the day after tomorrow. And yeah, that's about it. Have a nice evening.